Hello everyone, welcome to this video. In the previous video we have seen how can we calculate the standard deviation. Now here let me define another term which is the variance, and it is basically the square of the standard deviation that we used to calculate. This standard deviation used to tell us how much is the spread of the given data about its mean, whereas variance, this also is the measure of spread of the data, right? So we denote this variance by sigma square, and R.A. Fisher in 1918 coined this term variance, and he also gave the formula to calculate the standard deviation. As for an example, so consider this question: calculate the mean and variance from the following data. So here daily wages are given to us, and the number of workers have getting all the wages between 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60 were also given to us. So that means here we are given the class intervals, and here what we are to do, we are to calculate the mean and the variance. So we can calculate the mean by several ways. So we can use the step deviation method for that. For that we have to write this daily wages here as the first column, then number of workers as the corresponding frequency obtaining the wages between these intervals. So when you add up all these frequencies downwards, 2 plus 7 plus 10 plus 5 plus 3, that comes out to be 27. So that becomes your n, that is the total frequency. Okay, now in case of class intervals, whenever you have class intervals, then how do you calculate the mean? First of all, you take the midpoints of all the class intervals. So what you will do, 0 plus 10 divided by 2, so that is equal to 5. So we have the midpoint here. So this column represents the midpoint of all the given quantities here as the class intervals. Okay, so 10 plus 20 divided by 2 is 15, and so on. 20 plus 30 divided by 2, that is 25, 35, 45 and so on, right? Now here we are assuming our mean. So in this case we are assuming the mean to be 25. So it could, according to the formula, vary from 25 because we are making this by assumption, the mean, right? The actual mean could be something else also. So according to that, our formula would be this: assumed mean plus sum of the deviations according to the given formula, right? So we have A plus summation f into d dash divided by n into I, where what is this I? I is the length of the interval, which is 10 here, right? 10 to 50, 30 to 40, so that means it is 10, and we will we also know what is n. N is equal to 27 here, so this is 27, and A we have assumed to be 25. So this is by our assumption. We can choose any other quantity as well, and for this thing summation f d dash, we have to calculate this quantity. So let's see how can we calculate that. For calculating d dash, firstly we have to calculate d. What is d? D is m minus a. Now m is the middle value that you obtain in this particular column. So what is d? It is m minus a. And what is a? A we have assumed to be 25. So it is 5 minus 25, that is minus 20. 15 minus 25, that is minus 10. And 25 minus 25 is 0, 35 minus 25 is 10, 45 minus 25 is 20. So this is how you obtain the value for small d. Then we calculate this d dash. This is obtained by dividing it by the length of the class interval, and we know here the difference in each of these, the class interval vary from 0 to 10, so that means difference of 10. 10 to 20, that means difference of 10, so we'll divide it by 10, right? So minus 20 divided by 10 is minus 2, minus 1, 0 by 10 is 0, 10 by 10 is 1, 20 by 10 is 2. So this is our d dash. Next what we will do, we'll multiply this d dash with the corresponding values for f. So this is what we have, 2 into minus 2, that is minus 4, right? So similarly obtain all the other values in this particular column. and then once you have f d dash, this is required in the variance, right? We also require f d dash square. So what would be that? It would be this is our d dash, so its square would be minus 2 whole square into f. What is f corresponding to this? So in the same row we have the value of f as 2, so into 2, so this is equal to 8. So this is what we obtain. For the next term, our f is equal to 7 here, right, and your d is equal to minus 1. So what do you have here? You have 7 into minus 1 whole square, so that is equal to 7. So similarly, you calculate this, this and this, and then you add up all this, so you obtain summation f d dash as 0 and summation f d dash square as 32. So therefore your mean in this case becomes equal to 25 plus 0 divided by 27 into 10, so that is 25 only. So basically whatever you actually you by chance assume the mean to be 25, and the actual mean also comes out to be 25 here. So this occurred by chance, right? So next we'll see what is the corresponding variance. You know, variance is the square of the standard deviation, and we know the formula for standard deviation is summation f d dash square divided by capital N minus summation f d dash by n whole square into I square, right? In standard deviation it was square root of this quantity into I, but here the square root is missing and we are squaring this I. So I is basically 10. Summation f d dash we calculated to be summation f d dash whole square, that is 32. We just calculated this here, and then the value of summation f d dash, that is 0. So this is what you obtain. This is the variance of the given quantity. Okay, now let us next define combined standard deviation. First of all, why this combined standard deviation is required? That is the main question. So for that, suppose we have two groups. So in a given class of students, a teacher divide whole of the class into two groups. One will go to library and one will study in the class itself, right? So according to that, the first bunch of students have the mean, suppose the random variable is the height of the students, right? So here the mean for all the students, suppose that is denoted by x1 bar, and the corresponding standard deviation is denoted by the sigma 1 for this first group. And for the second group, suppose the mean height is denoted by x2 bar and the standard deviation by sigma 2. So we can calculate what is the combined mean. So combined mean of whole the class. Now I am interested to calculate the mean of whole of the class. I know the mean of first class, I know the mean of second class. So instead of going going from the scratch and calculating the mean for using the individual heights of the student, what I can do, I can utilize these two means, and in effect I could obtain the combined mean, which is obtained using this formula. So what is this mean? It is x1 bar n1 plus x2 bar n2 divided by n1 plus n2, where what is n1? N1 students here. So n1 is the number of students which are present in this first group, and n2 is the number of students which are present in this second group. Okay. So this is the formula for combined mean, and similarly we can also calculate the combined standard deviation, whose formula is which is denoted by the sigma 1 2, and whose formula is summation square root of n1, that is the number of students present in first group, into sigma 1 square, standard variance of first group, plus n2, the number of students of second group, into sigma 2 square, that is the variance of second group, plus n1 into d1 square. Now what is this d1? d1 is the deviation of the students from this d1 is the variation of mean from this combined mean. So in this first case, for the first group, this deviation is calculated from the mean of the first group, and this deviation is calculated from the mean of second group. Okay, so accordingly we have n2 d2 whole square divided by n1 plus n2. So this is the formula So we can solve one question related to this. So the question here is, we are to calculate the missing information from the following. We are given group 1, group 2, group 3, and the combined information for each of these groups is also listed. So we are given number of persons or the number of data points that is available to us. So in first group we have 50, second group N2 that is not known to us, and for 3 it is 90, and total we are given 200, right? And the mean is given to be 113 for the first group, x2 bar that means not known for the second group, and 115 for the third group, and the combined mean is given to be 116. The standard deviation for the first group is given to be 6, for the second group is given to be 7, for the third group it is sigma 3, so that means it is also unknown here, and the combined standard deviation is given to be 7.746. So this is all that is given to us. Now here we are to determine this N2, what is N2, what is x2, and what is this sigma 3. So accordingly, it is very easy to calculate this N2. Why? Because we are given the total number of data entries here, the total frequency, which is 200. So therefore this would be equal to the sum of these three. So that means if I call this to be N1, this is N2, this is N3. So you have N1 plus N2 plus N3, say this is N, is equal to N. So you have 50 plus N2 plus 90 is equal to 200, and so therefore you have N2 is equal to 60, right? So this is equal to 60. Now the next task is to first calculate this mean. So we'll use the formula for combined mean. So we know, because here there are three groups, so therefore the combined mean is denoted by x bar of 1, 2, 3, right? So this denotes the combined mean. So its formula is given by the first mean multiplied by the first number of elements, the second mean into this number of elements in the second group, third mean into the number of elements in the third group, divided by the total number of elements. Now here x2 bar is not known, whereas we know all the other quantities. So this quantity is not known. We know the value for this one. This is given to be 116 here. If you notice, this value is given to us, and then we are also given x1 bar, that is given to be 113. We are also given x3 bar, that is given to be 115, right? So we have here 113, here 115, x2 bar as such, this we have to calculate, and the number of quantities in group 1, they are 50. For second group we have just calculated this to be 60, right? So we have used the same here, and for N3 it is 90, and total is 200. We also know that. So we can do the computations here and solve out this equation where we have to determine what is x2 bar. So we can simplify this expression, and finally our x2 bar comes out to be 120. So this is the value that you obtained. This is the mean for group 2 using the combined mean, which you have calculated using the combined mean. So next, let me calculate the standard deviation. So the corresponding standard deviation is this combined standard deviation is given to be in the question 7.745, combined standard deviation for all the three groups. So accordingly, its formula is equal to square root of n1 sigma 1 square plus n2 sigma 2 square plus n3 sigma 3 square plus n1 d1 square plus n2 d2 square plus n3 d3 square divided by n1 plus n2 plus n3, that is given to be 7.745. Now we have n1. What information is missing here? Sigma 3 is missing here. Everything else we have. This is sigma 1, this is sigma 2, and this is sigma 1, 2, 3, right? The combined standard deviation. So we can substitute all the values here in this expression. So before doing that, we have to calculate these deviations. So what are these deviations? According to formula, this is x1 bar minus x bar 1, 2, 3. For D2 it is x2 bar minus x bar 1, 2, 3, and for D3 it is equal to x3 bar minus x bar 1, 2, 3. The subtraction of all the given means from the combined means, right? So this is what you get. So because we require the square of these quantities, so these are the squares. Now we are ready to substitute all the values here in this particular formula. So when you substitute all these values here, in place of n1 we have 50, in place of n2 we have 60, in place of n3 we have 90, and the combined value that is equal to 200. Moreover, sigma 1 square that is given to sigma 1 is given to be 6, sigma 2 is given to be 7, sigma 3 we have to calculate, so this is unknown here. d1 square we just calculated to be 9, this is 16, this is 1. And this is given to be equal to 7.745, the combined standard deviation. So now we just have to simplify this and we have to calculate what is our sigma 3. So when you solve out this and you compute, the value of sigma 3 comes out to be 8 here. So we have computed all the three values. N2 we have computed to be 60, the mean for the group 2 that is 120, and the standard deviation for the third group that came out to be 8. Once you know the total frequency of all the three groups, you know the combined mean for all the three groups and the combined standard deviation for all the three groups. So I have a question for you. So this question says that the mean weight of 150 students is given to be 60 kgs. So in total we have 150 students and their mean is given to be 60. So this is the mean weight that is given to you. The mean weight of boys, so out of total students we have two categories, one is for boys, one is for girls. For the first category, boys, the mean weight is given to be 70 kg, right? So this is given to us with a standard deviation of 10 kg. So that means each boy is nearly 70 kgs with a error of 10 kg, right? So a few boys could be 10 kg less, others could be 10 kg more, and so on. And for girls, the mean weight is 55 kgs and the standard deviation is 15 kgs, right? So here what you have to do, you have to calculate the number of boys, how many boys are present in that particular class, the number of girls, and the combined standard deviation. So these things are to be calculated here. So suppose our first group is that for boys, the second group is that for girls, and we have the total here. So number of boys you have to calculate, number of girls you have to calculate, total you have 150, and the mean for boys that is 70, the mean for girls that is 55, and the total mean is also given to us, which is 60, right? And standard deviation for boys is given to be 10, for girls it is 15, and the combined standard deviation is missing. So you have to calculate sigma 1, 2 here. So you have to calculate this n1, n2 and sigma 1, 2. So this is an exercise. The answer is this. You can try this question by your own. So here till now we have been calculating the mean and the standard deviations. Now suppose if during the computation some error has been incorporated into the given data. So what is the solution then? Do we have to do all the computations all over again? Now you will argue that it's okay, I can do the calculation again. Why would I go and learn this new method? That this new method is required whenever you have large data with you. So you cannot go again and calculate all the mean and standard deviations again. So here what you can do, you can rectify or you could improve the correction in your results. So let's see how this is done. So the question is for a group of 100 observations. So total we are given 100 observations. The mean and standard deviation were found to be 60 and 5. So they have given you the mean, they have given you the standard deviation. Moreover, they are saying later on it was discovered that a correct item 50, so 50 was the correct item, was wrongly copied as 30. So instead of 50, the person wrote 30 and made a mistake. Now without altering, because we do not now have all the calculations here, all the observations here and all the data here. So what we are to do, we are to correct the mean and the standard deviation according to this mistake. We only know that instead of 50, the person wrote 30. Okay, so for that, what information we have? We have the total observation n as 100, the mean as 60, the sigma standard deviation as 5. So that means these mean and standard deviation, they were the incorrect observations. Now we have to correct them. So we know the formulas. Calculation of correct mean. So first of all, we have to calculate the incorrect summation x. How can you do that? You know the formula for calculating the mean. It is sum of all the observations divided by the total number of observations. And we know the wrong mean, that is given to be 60. Total number of observations, they are given to be 100. So we can compute this incorrect value of summation x. So that comes out to be 6000. This is the incorrect value of summation x. Now in order to calculate this correct summation x, what you can do? From this incorrect summation x means that is the sum of all the observations. So from that, what you can do? You could add the correct item and subtract the incorrect item. So that means here, this is the total sum that you obtained 6000. Here you will add the correct item, which is 50, and subtract the incorrect item, that is 30. So this is your new or the corrected value of the sum of all the observations. Now you obtain the correct sum. It is very easy to calculate the correct mean. Correct mean is obtained when you write the summation x, the sum of all the observations which are correct in nature, and you will divide them by the total number. So this is the corrected mean. This is the corrected value for mean. Similarly, we can also calculate it for the standard deviation. For correcting the standard deviation, firstly we will utilize the wrong information. So for that, this is the formula for standard deviation. We know this is sigma, which is equal to square root of summation x square divided by n minus x bar whole square. So this is what you have. And you know the incorrect value of standard deviation in the question is given to be equal to 5. So this is given to be 5. And you now have to calculate what is this summation x bar. So here all these quantities, they are incorrect, right? So they have been calculated using the previous values of data, that is using 30 instead of 50. Okay. So now this thing we do not know. This we know this is 100, and the incorrect value, right? The incorrect value of mean, that is also known. That is known to be 60. The incorrect value of mean, right? So using this, you substitute it here, and accordingly you can calculate this summation x square. That comes out to be 362500, which is the incorrect value of summation x square. Now in order to correct this quantity, what you can do? In order to correct this, you can add the correct item. Now this is what? This is the square of every quantity. So here you are to add the square of correct item and subtract the square of incorrect item. So correct item was 50, so we'll add 50 square, and incorrect item was 30, so we'll subtract 30 square. That comes out to be 36100. So this is the correct value of summation x square. We can now substitute this correct value here in this formula to obtain the correct value of standard deviation, and here also we will use the correct value for mean. The correct value of mean we have just calculated to be this 60.20. So this is the correct value for mean. So now let's use this value here to calculate correct value of sigma. So this comes out to be, so we'll substitute it here. So this is 364100, and the correct value of mean, that is 60.20, right? This is the value. Now this is equal to 4.12. So that means the correct standard deviation here is 4.12, and the correct mean comes out to be 60.20. Okay. So next let us discuss the merits of using the standard deviation. So by far we have already understood it very clearly. What is standard deviation? How can we calculate standard deviation? So the advantages of using this method is that this method is rigidly defined. That means it has a very crisp formula. So you obtain that formula and you obtain your measures of dispersion. Moreover, this method of dispersion is based on all the observations, and this is not much affected by sampling fluctuations. So that means if you change your data a little bit, there won't be much effect on the value of standard deviation. Moreover, mathematical treatment is also available because this sigma is used in many other applications, for example in various distributions, and and also in the testing of hypothesis we use this variance and standard deviation. However, the demerits of this standard deviation is that because of the well structured formula for the standard deviation, it becomes difficult sometimes to understand and calculate. The calculations become quite lengthy, and moreover, this measure of standard deviation that give more importance to the extreme observations. So I hope this is clear to you all. Well, that is it for this video. Thank you for watching.